Uday Kumar, you can start.
Okay, ma'am. Okay, ma'am. Welcome to the day 2 session, National Level Faculty Development Program on Artificial Intelligence in Digital Era. So I may request Dr. Bhargavi Devi, ma'am, Assistant Professor from the Department of Computer Science, to introduce the chief guest for the day. Ma'am.
Yes, sir. Good evening, all. It is a great pleasure to introduce Dr. K.B. Priya Iyer, IQAC Coordinator and Associate Professor, PG Department of Information Technology, MOP Vaishnav College for Women, Autonomous, Chennai. Dr. Priya Iyer is an eminent academician and researcher with over 22 years of teaching experience in computer science. She has published 4 Indian patents, 2 books, and over 40 research papers in reputed Scopus and UGC CARE journals. She has also delivered recorded lectures on deep learning for Swayamprabha Channel 10, an initiative of the Ministry of Education, Government of India. She has successfully completed an ISSR funded research project. Presented papers at international forums in Singapore and Dubai. Dr. Priya Iyer has served in several key academic roles and contributed extensively to conferences, journals, and editorial boards. Her research interests include machine learning, data analytics, data mining, and we are truly honored to have her with us today to speak on the topic deep learning and neural networks. Welcome, ma'am.
Yes, ma'am. Thank you so much. Shall I take over the session?
Yes, ma'am. Yes, ma'am. You can take over.
Hope my screen is visible.
Yes, ma'am. It's visible, ma'am.
Yeah. Good evening to one and all. And I thank the SRM management, organizers, and Mr. Uday Kumar sir for giving me this opportunity to take this session on deep learning and neural networks. And before moving on to the session, this is basically gives the faculty members an idea of how to go about in deep learning using the neural network methodology. So we are not moving into very deep into the concepts, but the basic concepts, what it is, what are the different phases that comes across the deep learning models, and how a particular scholar or a teacher can take a course of in the deep learning will be elaborately discussed in our session. So here the agenda of today's session is to give an introduction with respect to deep learning and neural networks. And what's the main difference between machine learning and deep learning? How any of the deep learning models can be perform, how they will do the performing or optimization, what will be the modeling steps we have to follow at each and every phase. The different components of what a deep learning is, it's different architectures that are available, major advanced applications, and case studies. So moving on to the exact definition. Once again. Yeah. So here we come across over the years, we all are the teachers and we do different kinds of programming over the years. Initially, we start with C, C++, Java, and then we moved on to web programming based languages. And then we moved to the Python, whereby we come across these kinds of web programming languages. And then we moved into the AI. Artificial intelligence, machine learning, and the deep learning. Here we have to understand one thing across the programming languages. Here, what makes Python a little different and what we are working on. So this is a methodology whereby we as the teachers, we instead of making the system to work, we make the system to think as human beings. So deep learning is a methodology in artificial intelligence which helps us to process the data that is inspired by the human brain. So how we think, we make the system to think in the same way. Whatever we do in our daily processes, the same thing is being automated. So these deep learning models, they will actually recognize the patterns. They form the learning. They can analyze the pictures, text, sounds, etc. These all we already know because this has been very booming over the last 7 to 8 years. Everywhere we come across AI, ML, and the DL. So we already know all these definitions as we are the teachers. So to mainly focus on what is the actually meaning, here something will be given as an input. We already know in our computer things, some inputs has to be given, processing has to take place, and output will be displayed. Now, when you consider here for deep learning, see here in the given picture, there are different input parameters given for any of the modelings. It undergoes several different hidden layer processing, and as an output we come across what we wish to acquire or we have to get as an output objective. So if you consider this is a little bit imitates with our human brain. It mimics the human brain, and that concept we call it as a neural network. So when we coined the word neural networks, it means that it mimics the human brain for processing. So how it does? What's the main difference here now? So there are the input layers are nothing but the parameters we consider. The multiple hidden layers are the processing phases of the images. So for this, we should first of all know the next one called the machine learning and the deep learning difference. Then we will move on to the previous slide of the neural networks. When you consider machine learning, we come across how a particular data will be the textual information that is in Excel format, structured way. If the information is there, you can just analyze the data and you can do three things. We as a teacher, we already know we can either study the previous trends, or we can learn the current system, or we can predict the future. These are the three things we can do as part of data analytics in case of a machine learning. Okay, so it works for structured data. There are many different popular algorithms while working with machine learning. Some of them is the support vector machines or the k nearest neighbor or the decision trees, which helps us to analyze what type of analytics we are performing. Either we can go for prediction algorithm or to understand the descriptive analytics. Okay, so these are the different three ways of doing with the analytics, and there are many different algorithms to do this in case of the machine learning. So when we come across here, if an input is given, features are extracted, you can very well say yes or no whether that particular thing is a car or not. Okay, so tabular kind of information is being processed over in the machine learning. While you come across the deep learning concepts, it very well works for unstructured data. It can be any audio file or a video file also, not only the textual information. So here the algorithms, we call it as an architectures, we call with different nomenclatures which mimics the human brain. So they are the CNNs, RNNs, or the GANs, or the transformers. So these are the different architectures which are helpful to analyze the model performance. We come across in the subsequent slides about each one of these. Now here, when you see the difference between ML and DL, here features will be extracted, okay, and basing on the classification. These both are intermingled and combined to give the deep learning concept. Okay, so here the same output comes, but here it undergoes a different methodology whereby the phases of feature extraction and classification is being combined. Now moving on to the neural networks concept. I said it mimics the human brain. So here if you say the x1, x2, xn are the different factors. Suppose you consider we want to judge whether a particular object belongs to particular category or not. So the input parameters will be the judging parameters, and for each of the input parameters we need to assign a weightage, which tells that how far that particular model efficiently or accurately predicts that, or it conveys that model accuracy. So that weightage has to be given. These two together will undergo a summation process, and in turn it follows an activation function. I'll just come in other few more slides informing you or giving you an explanation of what an activation function is. By applying this activation function, we will get whether the model is being accurate or not. Okay, so by time being, we understood that neural networks is a concept which mimics the human brain, whereby input will be there, many hidden layer processing happens, and then the output is being produced. Okay, now moving on to the model steps. We already know that the teachers who are already taking machine learning or deep learning papers in data analytics or data science domains, they already know these are the steps. Okay, so we need to first initialize our weightage for each of the parameters. Some weights will be given, initial values has to be assigned, and this any data what we are taking either from the GitHub or from the Kaggle, the data sets images will be taken. So those images will be classified into either 80-20 or 70-30 percentage, whereby some part of the data will be taken as the training data, some part will be taken as the testing data. So moving on, this input data is fed to a neural network which is performing a forward propagation, and here we calculate any loss is there. We just see the difference between any of the what is the prediction we have done and what is the actual output we got. So this calculation will be done in the mean hidden layers, and then if some error is there, some methodology or the model accuracy is not up to the mark, we will just propagate the error backward and adjust the weights again. In each of the phases, there will be a methodology to do that, and we need to adjust the values for all of the input parameters. Basing on that, again, applying different kinds of optimizations and reducing the loss, thus any of the models can be well trained and optimized. So these are the steps while doing any of the deep learning projects. Now, in detail, to have an eye of these phases, here and forward propagation means it moves on from one layer to the next level until all layers are reached. This is the general explanation. We already, everyone knows of it, what is forward. While moving on to the backward, it's again an iterative chained process whereby in each of the things, in each of the phases, what we will say is how much a neuron has to contribute, how much it can contribute to the model performance. So the errors have been back propagated and they will be corrected. These errors will be given a good weightage. Each of the neuron here is nothing but one of the input parameter. So like this, these two phases goes on. Now in between, there are something we have to understand while we are taking the code from any of the online sources. Actually, for each and everything nowadays, the code is available for the implementation. We need to just understand what the individual phases of the code such that we can train our students in this particular area. So when you come across the optimization methodology, here this is a technique whereby some algorithms have been used called as gradient descendant. And many different methodologies are there within this gradient descendant method. This is mainly used to optimize the networking values to have a better performance. How this methods has to be used. Python has a varied libraries to produce or to give or to support all these functionalities. So we have to just call that particular respective gradient descendant method and apply in our program. If the accuracy is very much little or more, accordingly we will change the gradient methods or the types. Now activation function, what it is? Activation function is the terminology that is being used to convert our input to an output, whereby this says that whether the neuron has to be activated or not. Out of 15-20 neurons, you want to activate only 10 neurons, 5 neurons has to be silent, abdina, then that particular Bayes value or weightage value for all the activation functions will be decided by this method. So here there are many different kinds of again activation functions. We call it as a linear model, sigmoid, tanh, ReLU, etc. So these keywords will be using of when we are doing our programming part. Then the other concept is called the loss function. Here the loss function, the nomenclature itself says that it is an error function. While doing the calculations, we need to understand in each and every phase there might be an error. So how far the values have been predicted, that error is being calculated with different methodologies. Again, many different loss functions are there. So depending upon the problem, we can use one particular error method, and then we will see the accuracy whether it is changing or not. So one of the methods is the mean squared error method, and this mainly used to say that how well our neural network is being performing. So moving on, we got many different buzzwords associated with any deep learning model. I will show you real case study examples taken only from the online sources. Those, in understanding those codes, these are the words that frequently we will change in our coding. So one is the loss function. It is actually evaluated against the real values. So this real values, the difference will be computed over here, and we will be using many different mean squared error value. The second terminology is the gradient descendant method or the optimization algorithm, which is used by the network to reduce the loss. So any inaccuracy is being there, we will change the weights basing on the loss that has been incurred in the model. Then the third one is the adjusting of weight. So different parameters we are taking, and in each of those parameters, we will be applying some of the weightage for the neurons in each and every phase. Okay, those values will be adjusted over here. And the actual training phase, we will follow forward propagation. We will do all the last calculations and then the backward processing. Now moving on to the last one is the activation functions, which actually helps whether particular neuron has to be activated or not. Here neuron means we have to understand they are all the input parameters. Now moving on to the other things, other major buzzwords which will come across while we are writing our coding part. So one thing is the learning rate. These other things we have already discussed, the gradient descendant method, the loss function, activation function, and some hyperparameters. We will first see what is the exact definition of all this, and what is their role when we do the modeling, and any example methods or different types are already available or not. So first one is the learning rate. This says that it's a parameter which controls how much weights are updated during each of the training phases, and it actually determines the stability of the convergence, and it will be too high if you overshoot and too low when it is a slow learning procedure. And the typical values that can be adjusted for any learning rate can be between 0.001 to 0.1. While moving on to the gradient descent methodology, I already said many different built-in functions are already available in Python libraries, and this algorithm actually minimizes some of the loss functions by moving the weights in the direction of the negative gradient. So this updates the model parameter iteratively to reduce the errors only. And many different variants are available. There is a batch gradient descendant, stochastic gradient descendant, mini batch method, Adam method, RMS prop method. Here, each one is used for one particular purpose, and we are not here to discuss the pros and cons of each of the methodologies. We can have the library functions and we apply to any of our real life applications. We can see the variation in the output. So accordingly, we can just change our gradient descendant methods. Then the loss functions, I said many different variants are available. It's mainly used to calculate the error value, and it makes a difference between the predicted value and the actual value. How we are doing is the difference. Whether we are taking it mean squared error or whether we are doing for a classification problem by applying cross entropy method or a binary cross entropy method. There are again many different variants, 7 to 8 different loss functions are popular with respect to any of the applications like text processing or time series data or object detection, or when you have a motion tracking system. So depending on that, our loss function will be different. We have to choose that. Then the activation functions, as informed, it mainly says that whether a neuron has to be fired or not, how much has to be fired, how much has to be silent, that particular neuron has to be. It mainly helps the network to learn the complex patterns. And the types are the sigmoid, tanh, soft X, or the ReLU, depending upon the application again. So these and all, we can, as teachers, we can just go through that. What are the different types and which type is used in what type of applications? We can just have online resources to know that. Okay. Then with respect to hyperparameters, there are little bit variance when you are applying this. You can know about the learning rate, batch size, or epochs, how many times we are executing our particular modeling to have a better accuracy methodology, or we can calculate even the dropout rate. So these are the different terminologies that have been used in deep learning models when we do any programming part. I will just show you where these comes upon when we see an example case study. Okay, now moving on to the architectures. So what we come across machine learning and then the deep learning. We feel that as teachers, this deep learning deals with mainly image image processing or object detection or motion detection or text to image generation or some text to audio generation or something with respect to video phrasing. All these comes under the deep learning models. Something that deals with images in a massive fashion, we can say it as deep learning models only. So how to do this? What are the different architectures that helps us for this? Okay, so convolution neural networks, recurrent neural networks, and LSTMs, short-term memories. Like this, we have 6 to 7 or 8 to 10 different kinds of architectures. And here in this slide, we come across what are the different applications for having this. When you take the CNN network, it's for all these architectures, there are already built-in functions available in Python libraries. So we will be using all those things. CNNs are mainly used for image recognition or object detection and classification. When you do any language translations or any text generations kinds of modeling, we can go for the recurrent neural networks. And when we use any type of long sequence of text, when you use any vocabulary or the text can be like recognizing a handwriting practice or some prediction of stock prices, you can go for LSTM architecture. Now moving on to the text to image synthesis. Nowadays Dolly or many other online apps are available. If you say any text, the image is being generated by AI. We come across many AI applications recently, tools for all our research activities or day-to-day presentations, anything AI technology we are applying as teachers. So here this GAN architecture is mainly used for image generation or video colorization or text to image synthesis. So these kinds of applications can be well suited when you take a GAN architecture. Now autoencoders, reinforcement learning and transfer learning, these are the other things that are already available and they mainly use it for the applications that performs with the deep learning models. Now moving on to the comparison, a little comparative between these two. As we already discussed, for image processing CNN, RNN is mainly used for the time series or the textual information processing, and mainly for image training you can take the GANs. Now, what are the different latest applications? By this, we will just move on to the actual coding part, whereby how this can be from any online source, whatever the application we are taking it, how we can apply to our data set. When we have our own data set, we have many online sources. Okay, all the codes are available in GitHub. But how we can apply for our own research purpose? We have a data set. How to apply that? Which lines has to be changed? We have to just go through with respect to the coding part. Now, moving on to the latest applications. Nowadays, it's a Gen AI, generative AI. It powers the deep learning and it creates us new text or code or designs like that. So whatever nowadays we have the prompt engineering. So as and you was versed with the prompts, we can very well create whatever the content we want. Any PowerPoint presentation we are creating online, any image generation by giving a description of text, the system is providing us with the whatever is our expectation that is being satisfied. So these types of applications are even is possible with the deep learning models only. Or we can have even the advanced customer support chatbots whereby they can understand our user queries and they provide multilingual support. This is one of the best applications we can say, because one developed the particular FAQs in one particular language and we can ask the AI to give it to the customer based things. And in healthcare and other diagnosis still, these deep learning models are very well help to detect the anomalies. They helps in diagnosis. And moving on to the autonomous systems, we know crucial applications are the self-driving cars or the drones or the robots. They help for the real-time sensory of data. They understand the environment and accordingly that particular model reaction is being taking place or the navigation takes place. Fraud detection systems, they analyze the suspicious activities either in banking or financial applications, and they protect us from the unauthorized access. So all these kinds are the, we can say, some of the applications of the deep learning. Now we will move on to the actual real case study examples, which I have taken from the online resources and been executed with the Google Colab. So moving on from the first application, see here, it will take much time to execute now each and every application. So I have taken this code and I have taken time to execute all this. We will just see how the code is being structured. I understand the participants are new to the deep learning part and they want to do some research with respect to the deep learning applications. Okay, might be some teachers are already handling the paper. They might be well versed with all this coding. And I feel that the session has to give some insight to at least the research scholars or some teachers who will take the paper next time to just see how the deep learning works. Now, one of the applications is the handwritten gesture or something written with the hand, that particular image, how it is being analyzed by the deep learning models. And for doing so, many different libraries are available in Kaggle or GitHub. We will take the data set from there, or any online data sources also can be connected and taken over. And the project has to be reframed in such a way how we apply to our data set. Now, if you move on to here, the first few steps, only for the sake of explanation for the new novice users of deep learning, here everything I said, Python libraries, the coding or built-in functions are available. So this is possible only with the different libraries like Keras or the TensorFlows or the PyTorch. So there are many different libraries which helps us to do each of the building modeling with the applications. Now, if you say this is an import statement whereby you are downloading the libraries for your program, and that libraries that are needed are the TensorFlows, Keras, and the Matplotlib. Okay, so this statement gives us the information that we are taking the MNIST dataset that is already available online, and the dataset has been taken in such a way it is splitted into the training and the test formats. And here we are normalizing the values between 0 to 255. This says that whatever may be the image pixel, we are converting or refining or reducing the image size from 0 to 255 only. That will be easy for the processing. So any value can be between zeros and ones only here for processing. Here again, excuse me, these two lines explain that while we are taking any of the image shape, we need to tell the deep learning model how many layers, how much is the pooling layers we are going to take. And we need to say the image is of which grayscale. So these two lines helps us, the reshaping function helps us saying that whatever may be the image, take the 0th image, first image, and then we are saying or applying some of the layering methodology such that the grid structure we will be taking is 28 cross 28. Okay, now here this particular line says that we are applying a model, CNN model, that is convolutional neural network model, and see the different parameters we are going to supply in this model. Each, whatever we discussed till now, what makes a deep learning model, we need to consider the loss functions, the activation functions, what gradient descendant method we are going to use for that particular model, and how much is the learning rate or epochs, how many to execute. All these values will be given only in this part. So if you see, there are many different architectures. Depending upon our particular program, we can change this and we can see each and everything. It's not necessary that taken from the GitHub, we have to use the same thing. For teachers to understand and convey to the students easily, first in this program, see here, we have taken the convolution 2D method, activation function ReLU is being applied, and the shape is given as 28 cross 28. So we can even change. We can move it to sigmoid method, or we can move it to the other activation methods, TANH, and see for the same project how much accuracy we are getting. Even softmax layer is being applied over here. And here when you are applying, we are saying for each and every grid method, that particular image, how to use and what grid we have to take. 3 by 3 is being taken and 2 by 2 is being taken. It's not necessary we have to take this. When we do our own project, we have to see by giving input values, by changing these parameters, and see how well the model accuracy has been increasing. And when we consider what input parameters, the accuracy has been increasing. So these are all the things we need to supply. For the layers, we are applying convolutional 2D, and max pooling is being taken for us. There are different pooling methodologies. There is an average pooling methodology or a maximum pooling methodology. What this says is any particular image will be stored in zeros and ones only, right? So if you take any grid, whether that particular pixel is been on or off, we will represent with the values of zeros and ones. When you filled up any particular image with these grids, this max pooling says that within that grid takes the maximum value. We are shrinking that image. Image will be of a major pixel, 1024 into 1024. But while we are processing, we will not take the image that much of input kind. We will reduce that. Okay, and we will apply either average pooling methodology or maximum pooling methodology, because it varies. No, when we have an image, we need to understand what that image is. A cat is a cat, we have to say. A dog is a dog, the system has to say. So what are the major things that makes a cat to be represented will be understand only by giving input in this particular thing. So these layers have been defined, and 32 has been given in the first activation for an input shape of 28 into 28, and then convolution 2D is being applied again to the 64 value, and the activation function ReLU is being given. So all these are the input parameters, and this will each time you are adding the layers, okay, flattening the layers, adding the dense layers, and minimizing each time by applying some activation functions. By doing so, we are compiling the model. Now our model is being ready, and the model is being compiled with gradient descendant methodology called the optimizer algorithm. So optimizer algorithm that is being used is the Adam algorithm, and the loss function that has been used to calculate is the sparse categorical cross entropy method. These and all, we can even change, execute, it will take more time. When you have to execute one particular thing, maximum 10 to 15 minutes it will take. So this has been, I have executed in Google Colab. Even if you have an offline, all the libraries being installed, no, then it will be a little quick also. So while compiling, we need to choose our algorithms, and for whichever methodology the accuracy is more, we will just fix up with that. Okay. Then here we are modeling. We are fitting the model for training and testing data. See here, the validation part is being taken for the testing part, and input values have been taken for the training part. Now 5 epochs have been used for running this. See here, these epochs represent how many times we are back propagating and re-executing the things. So it will say how much ever layers, how many repetitions we are doing. Sometimes epochs, giving more number of epochs will reduce our model accuracy. We need to choose and give it correctly. Okay, ideal can be either some 3 to 5, that's it. And if you have a big project or something which takes a complex things, the epochs can be increased. Now here, after doing everything, the model is being evaluated, and the accuracy percentage is being in the test ACC that is being printed. And this has been shown as a graphical method whereby the accuracy and validation of the accuracy with the training data is being displayed over here. We already know that this shows that the shape that we have taken and what is the image that has been predicted. So the particular model is first trained. Here see, now a sample of that is being taken, which is a fifth image, and we are calling the same model to predict it whether the image, fifth image that we have taken, correctly analyzing the handwritten gesture or not. So the predicted digit is being displayed over here. Now moving on here, we have given 5 epochs. So it is being executed 5 times, and each of the times the accuracy is being calculated. The loss function, how much we got, is being calculated. accuracy value, loss value has been displayed. Now here, how the model generates the CNN training accuracy is being given as a graph. And moving on to one test sample that we have taken is the digit prediction. Here, the images is already been given. Testing data is already there. So one, whether it is predicted one, how much is the accuracy is being displayed over here. So the predicted digit is 1. This is the first project we have, recognizing the handwritten gesture. Okay, so moving on to the second example, I have taken from the online sources. The second one, to analyze the sentiment analysis. This is the second thing. Now, we as the teachers, we know very well any online that has been taken while we apply in Google Colab or some IDLEs of Python like Jupyter or some other PyCharm or Anaconda or frameworks like that, we already know if we give this code, we will get the answer. We are very well sure of that. Now, how to explain to the students with respect to changing the parameter values, how the output is being affected over that gives us a clear explanation of the built-in functions. Now, if you see the second example of the sentiment analysis here, a data set is being taken. See, IDDB dataset is being taken. Here, there are already reviews with respect to the words. How much ever frequent words have been there, that particular sentiment analysis is being taken. And see here, maximum features of the words is 10,000 and length of the particular word for reviews is taken as one particular review. Length can be taken as 200 characters. Now, this statements are already just now we come across the previous example. Here, the statements takes a data set. Either it can be a built-in data set taken from this local system or any online data set, and that is being loaded into training and the testing data. And these two are again something different from the previous things, which says that how we are taking our sequence of words. This comes under the methodology of how there will be a review database. Users will be posting up the comments. From the comments, the system has to say whether it is a positive feedback or a negative feedback. Okay, so for this, the built-in functions that are used are the sequence dot pad underscore sequences. It takes the training data and find out the maximum length of both the data sets. And now again here we are calling a methodology called LSTM. In previous example, we have taken a CNN methodology and all the input methods, I mean functionality has been given with respect to gradient descendant methods or the loss functions, or we have taken the epos count. Now here we are training a LSTM model. We have to understand one more thing. Each and every application works with different architectures. So if that architecture is suitable for that particular application, we have to take only those architectures, which will gives us a better performance thing. So here, as any of the long sequence word processing falls under LSTM model, we are taking this. Now the layers have been embedded, input parameters have been given, which says that what features to be taken, how much is the dropout rate, how much is the recurrent dropout rate we have to consider while doing the backpropagation. And then we have applying a dense layer which says the activation function as the sigmoid activation functions. So after that, we are compiling the model using the loss methodology, optimizers, etc. And then the model is again fit for 3 FOs. And then test accuracy model is being evaluated over here. And this particular thing says us one input value being taken as from an array of test 0th one model is being predicted. So from the data set, it says that it's a negative sentiment. So predicted sentiment that has been taken from the data set, which is at the 0th line, is a negative sentiment value. So 3 epochs have been run. It had taken time to execute and the model accuracy is 82%. Now, I can even change the values over here, and by doing so, if the accuracy is being increased, my model has a well predicted one, we can say. So this 82%, how we can make it to 90 or something now? That is our way of dealing with the input parameters. How we gauge that what activation functions or something can be changed such that this gets increased. Our model accuracy is good. Those are all is our way of doing with the modeling. Okay. So moving on to the next one. So other one is to have how an object is being detected. So all the deep learning models, whatever we have nowadays currently is to detect an object. We know very varied applications like either in traffic or something with respect to smart IoT applications, sensor applications, how an user gesture is there, how to recognize a facial expression of particular user and compare it with a database of some millions of images. So these are all the things we have. And very well, robotic process automation or robot programming is how the robot analyzes an environment or sees the situation of environment, how it uh, detects each of the objects in the environment is another challenge nowadays. So whichever the model, how you are defining your model such that the object has to be first detected. In a frame of a picture, you need to identify all the objects, and then after identifying the object, you have to say which object is that. That is the application actually. So this is YOLO is one particular thing which is already built in model, and this model has already been have an way of recognizing either a bus or a car or some of the well-known objects of the world. Some of the limited images have already been trained over. You have to just use the input function, that's it, built-in function. So for this we are taking ultralytics and we are importing the YOLO library. And here there are many YOLO models are available in online resources. You can very well check that. The basic model I have taken over here, YOLO V8NPT. Here, this is a PyTorch thing, kind of thing, whereby if we use this built-in model and say that any particular from the online libraries, we are saying that to recognize a particular bus image. Okay, so this image has been taken as an input to model, and the results showed that from the input, the different objects has been identified. See here. So this is the output of that particular code. Here, we have to understand one thing. We have not developed the model. We have not written any code. We are using the old YOLO models that have already been built. Suppose for our real world data, if you want to apply, you can very well use that YOLO library, fine. But if your object detection does not comes under the YOLO built-in library, we have to, suppose you are doing a medical diagnosis for a tumor something, and you want to detect some particular part of an image whether that magnificent is there or not. In such a case, we need to have our own code such that that particular object or image is being recognized. See here, the entire sketch says that it's a bus, and some of the other pixels says that it's a person standing over here. So these are all already built in. We no need to write the code at all. You have to just use the built-in libraries to do these kinds of programming. Here snippets of codes are available, and these codes have to be taken, combined, and then we can apply for our own projects. Okay, suppose we have a moving video. That video has to be uploaded, and that video has to say how many objects have come across, or what are the different how one person have been come how many times during a day. Suppose you consider it's a webcam. Webcam, I mean, is the online camera application whereby you want to see the logs of one single person, how many times he have come across over the street at on a particular day. You want to see that, you can upload the person image, and through the video also running how many times his particular image matches with the video images. So each of the slot of the video, the objects will be taken off, and it can be compared with an existing image, and you can say that person has visited this place, or in the video the person is appearing 10 times or 15 times. These are the log times. So these are the our own applications. We can develop newer applications like this as part of our research. But existing snippets of codes are available to do what and how to recognize an object over a moving video, how to just say that particular image is being categorized to what method or what. And if you want to have a counter of success rates, then we can do how many times the matches comes accurately. Okay, so this the other application which says that how an object detection is done by YOLO. Sorry. So this is the third application which I wish to convey as part of the deep learning model. Then the other two things, it takes much time to execute. The other application is text to image generation, whereby we give our uh, explanation how our image has to appear. Prompt we are giving. So the DALI is giving us, or some other online resources are giving us that particular image, a generated image, depending upon the text. Now, how to do this particular project by our own? How we can do, how we can keep this project as one of the exercises for our student in a deep learning course. So there are many libraries you have to install for all this. And here the code says that, see here, you are taking from the id like YOLO built-in model. How we have taken this model, we are taking stable diffusion v1 5 model. This model is been already been modeled by the libraries, Python libraries. It's already available. We are just going to use that, and it gives the image generation for the prompts that are already there. So here, see, stable diffusion pipeline we are calling, and we are applying the pre-trained model that is already being taken as default, and then we are calling over here the pipe to have this particular CUDA to be available. And we are taking our prompt here. This is the prompt. We just want to have a city with some flying cars at the sunset. So three different segments have been given. Some city which is futuristic, some cars has to be in flying mode, and it should be an evening sunset time. So according to this prompt, we are just saying that to generate an image and show us the image. And this takes much time for me. I didn't get the requested output here. It has been executed, but the subsequent image has been generated. So this is the way how we can have these snippets of code and apply to our programming projects. So like this, you can even go for modeling a moving object tracking also. Motion detection also can be done. So we can have our webcam, and the code has been, see, I think this is the code that has been taken for detection of a simple motion detection also using OpenCV library. So it captures the video from our webcam, and it says that whether there is a motion or movement is there within the image capturing or not. So here we are again using the built-in libraries. We are asking it to capture and read that, and we are putting a boundary framework whenever an object moves over it. Okay, and within that framework, if the movement is there now, then we are conveying a message called an object motion is being detected. See here, motion detected has been conveyed over here. So these are the different input or the basic built-in functions that will be used to actually have the motion detection. So these are the simple projects which I have taken from the online resources to explain how it goes. So as a novice teachers, when you are moving a course or going to take a course next semester in deep learning, these are the practical sessions you can give for our students, whereby they can just play with this and change the functions, and they can build the model accuracy. They can improve the model accuracy. So these are all the applications I have for you, and I hope the session is interesting, and I have done justice. Yes. So
Participants, yes, ma'am, yes, ma'am, yes, ma'am.
yes.
Participants, if you have any queries regarding the session, you can unmute yourself and you can ask the resource. We have given unmute access to everyone.
Yes, actually, the thing is, these real world examples, for some who are not been done any of the deep learning projects, you can refer GitHub or Kaggle. Many datasets are already available and all the codes are also being available in online resources. We have to just take the Google Colab. If you don't have inbuilt Python, nowadays Python is being in part of a curriculum for almost any of the colleges. So we have to have our own Python libraries being installed, or you can use Google Colab. If it is a very long execution, we can use even take the help of the internet and then execute. So what is the main thing we have to understood is the code will be available in snippets. We have to apply to our problem wherein all the codes of the snippets we can take, and we need to change only 4 to 5 parameters and see how the model accuracy can be improved. Given any particular image, this is already been done. When you upload a new image only, you can say how much accuracy it is. Being in this code, the testing data only we have used, but in our research part and other things, we will give one more new image to the system and say that whether that particular image is being accurately diagnosed or predicted or not. So in such cases, you have to just change the variance with respect to the gradient descendant or error functions or the learning rates, so or the activation functions, and see that how well the model can be enhanced.
Thank you very much, ma'am.
Yes, ma'am.
The session was very informative, ma'am. Thank you very much.
Yes, ma'am. Thank you so much. And thank you, organizers, for giving me the opportunity.
Participants, if you have any queries, you can ask the resource person. Otherwise, you can post your queries in chat box. We will inform to. Ma'am, I think one query from the chat
Yeah,
box.
with respect to the tools, we can think of that all the online sources we already have. Then we need to just copy the code and execute in our part. In our editors. That's it. So everything is already a tool. The libraries are available. Yes, thank you so much. Shall I leave, sir?
Ma'am, 1 minute, ma'am. Any other queries from the participants? Okay. Thank you so much, ma'am, for your informative and thought-provoking session. Your insights have truly enriched our understanding and sparked our curiosity in the world of deep learning. Thank you so much, ma'am. Thank you so much. The feedback link is shared in the chat box. Participants, once you complete your feedback link, you can leave the call.
I can take a leave, sir.
Yes, ma'am. Thank you so much, ma'am. Thank you,
Yeah,
ma'am.
I thank the HOD and other organizers of Ramapuram branch, SRM. Thank you so much, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
वो बात नहीं है, वो लोग अपने को परमिट नहीं करते हैं.
The feedback link is available in the chat box. Participants, once you complete the feedback, you can leave. The feedback link is open till 8:15. You have 10 more minutes to complete. To complete as soon as possible. And the feedback response will be closed within the close at 8:20 p.m. So try to complete the feedback. And it is also posted in YouTube chat also. So those who are all joined in YouTube, just check your chat box and you can complete the feedback. The Zoom call will be ended at 8:20 p.m. So try to complete as soon as possible. And the feedback link will be closed at 8:20. Try to complete first. Thank you.
पता नहीं मेरे को कहाँ से मिला लिंक, बट शी इज टू गुड। हमारे इतने प्रोग्राम्स होते हैं तो फालतू के ज्यादा होते हैं, बट शी 1 घंटे में उसने
Participants, try to complete the feedback as soon as possible. The Zoom call will be ended 8:20 p.m. and the feedback link will be disabled at 8:20. So try to complete fast.
Thanks, Uday Kumar, Vignesh, Bhargavi.
Thank you, ma'am.
Thank you.
Thank
I
you,
think
ma'am.
we can
Thank you, ma'am.
we
Thank you,
can
ma'am.
close, I think.
Sure, ma'am. Okay, we can close.
We
Yes,
can close.
Bhargavi ma'am, close பண்ணலாமா?
Yes, sir. The response close பண்றேன், sir.
Okay, ma'am. Thank you, ma'am. Thank you, participants. Thank you.